Okay, re-envisioning track-based microplate automation. So usually when you think about a track-based stack type system for automation, you think of them as being very fixed and inflexible and very prone to malfunctions and jams. You usually configure them to do simple tasks, maybe serving a single instrument, and they're very specific to the vendor that you're serving the instrument for. So you would expect that if you had a Hudson stacker, it would be in front of a Hudson instrument. Hudson's taken that paradigm and really thrown it to the wayside. So the Hudson LabLink system is very flexible and adaptable. It can work on Hudson devices or third-party devices. It can be reconfigured in the field very easily because of its modular design. And because of this, LabLinks can be applied to either a simple task where you're serving a single instrument, or it can be even be implemented into serving larger complex workflows. So a little note about this stacker that we have over here. So this is the StackLink. It's just the heart of the LabLink system. And it's not just a gravity-fed stacker. Inside of the stacker base here, there's a gripper that uses positive gripper control to guide the plates out of the stack down to the track that runs through the bottom of the stack. This allows you to run different types of consumable devices in the stacker, including shallow well microplates, deep well microplates, tip boxes with and without lids. And it also allows you to do things like shuffle the deck of the stacker to give you random access to anything that's in the stack. So what you traditionally think of when you think of a microplate stacker and a track system serving an instrument is a single instrument that is serving a single device. Here we're showing our StackLink serving our Micro 10 non-contact dispenser. And you can cycle through and serve all of the plates in the stack. So you can do a very simple implementation on the desktop where you add the StackLink, add the track, and you cycle it into a single device. You can also daisy chain different components of the LabLink system together to handle more complex tasks. Here we see a system where you have a StackLink feeding plates to a non-contact dispenser, then a plate washer, and then a sealer, and then stacking back up, allowing you to do more complex tasks than you would expect from a simple StackLink, a stacker type track-based system. What sets LabLinks apart is the control of the track. Each StackLink can control a different section of the track, so you can have different plates moving in different directions out of the StackLink. Here we're showing two devices being served by the StackLink, but instead of them both being served on one side of the StackLink, it's actually serving two instruments that could be doing two separate processes on either side of the StackLink. Because you have two stacks in the StackLink, you can shuffle through and gain access to any single plate or consumable that's in that stack and send it to an instrument on either the right or the left of the instrument. You can daisy chain StackLinks together to give you accumulator capacity in the middle of a process. Let me start this animation. So here we're showing a StackLink feeding plates out, and by including additional StackLinks in the process to accumulate or to provide incubation time, because we could heat or cool a StackLink if we need to, we can give random access of any plate in the stack, either pass through a stack to another instrument or passed serially through the process. This allows us to build as complex a system as we need to by mixing matching the modular components. So we have the StackLink, Then we have different levels and lengths of track link that we can be incorporating. The track links come in a 4-foot section, a 2-foot section, a 13-inch section, and a 6-inch section. And wherever there's a device that we want to stop a plate at to have some kind of liquid handling or plate washing or sealing or print and apply perhaps, we would put a stop link on that track that controls where that plate stops in the process. And by incorporating these different components, we can do anything from a simple system that serves one instrument all the way up to a very complex microplate handling system for a multi-instrument work cell. Once you're done with your process, the system isn't obsolete because all of the components can be taken apart, broken down, and reutilized in a different configuration. And the SoftLinks lab automation software controls the entire process regardless of whether or not it's serving a single instrument or multiple instruments. So here we're showing the SoftLinks lab automation software. It can control all of the different scenarios that I showed you above. So it can handle a single instrument. It can handle multiple instruments in a serial configuration, or it could handle separate instruments that are being served independently of each other on either side of a stack link. The SoftLinks lab automation software also controls all of our robotically controlled work cells, and it's a very intuitive GUI type drag and drop software program. If you've ever done a flow chart, you're more than prepared to write a program in SoftLinks. So because of this toolbox of components for lab links and this modular approach, you can do anything from a simple task all the way up to a complex integration. Here we're showing 2 stack links going across the deck of a solo liquid handler from Hudson Robotics. So the plate comes out, it goes onto the deck of the liquid handler. The liquid handler can perform the conventional function that you would think that any gantry robot type liquid handler could perform. In this case, it's taking an aspiration out of a deep well plate, doing a mix in a 24 well plate. And I hit the wrong button, I apologize. So what's interesting to see is that the track, because of the independent track control by each stack link, can move multiple plates in the process. And it can even go backwards and forwards with different portions of the track. So if you wanted to add some plates and go back into the beginning stack, I got to stop waving my mouse around. You could go backwards and put the plate back in the originating stack if you wanted to, or you could move it forward into the stack that it goes into at the completion of the assay. Here's another system with 2 components. So we're showing it coming out of the plate handler, goes through a barcode reader. Then the plates go into a plate washer. That's the Hudson Rapid Wash plate washer. And once the plate is done plate washing, it's going to go back down onto the Lab Links track and go forward into a non-concocted dispenser, the Hudson Micro 10. Finally, once the new reagents are dispensed into the plate will be cycled into the second stack where it could be accumulated for retrieval and going into another process or storage, or it can be accumulated to go further on into a process that would continue off camera to the left. Lab Links is also compatible with the Hudson lines of plate crane robots. So if you had a device that you wanted to handle that was not track compatible, a robot could lift it off of the track, put it on the deck of the device, and then put it back on the deck of the track. For instance, if you wanted to, say, go into an X peel to unpeel a plate, the track could come up to the plate crane could insert the plate into the X peel, then put it back onto the track once the seal was removed. Regardless of the type of plate handler, whether it's a lab-link system or the plate crane robot line, they're all handled by the same SoftLink software package. So having the LabLinks toolkit at your disposal, it allows you to perform a lot of segmentation of your process to make sure that you can maximize the throughput of your assay. So a lot of times when you have a larger work cell and you have more than 2 or 3 components served by a single robot, that robot might go on a track to serve more instruments that are further over in the work cell. Well, that takes a lot of time, and then the robot ends up being the bottleneck in the process. LabLinks allows you to take a robotic work cell and be able to segment the process, so you only have a handful of instruments served by one robot, and then the plate can go downstream on the LabLink system and accumulate in a stacker as it waits to go into another segment or island of automation in the process. So you see up here, we have a robot that's served by that's serving several different thermocyclers. When it's done with a plate in one of the thermocyclers, it puts it on the track and it accumulates in that stacker. And then you could chain these work cells together and have a continuous process where all of this plates can be scheduled so that they can then make it to the end of the track all in serial position as required. This allows you to do a very complex work cell that's very efficient with very little bottleneck or no bottleneck from the plate handling.
Steve, I'm afraid I have to break in because we've run out of time for this, and I've got to keep this on the timing mark.
That's okay. This is my last slide.
Do you? All right. Well, great. We can run into. There's a couple of questions here, but
Sure.
I'm gonna move on to Hans Christian Leuterman, and hopefully we can get back to those questions at the end. Okay.
Sure.